Today's lesson is on significant figures. Significant figures are important in chemistry because they can tell you a lot of valuable information. They can tell you if you are likely to have good results or bad results. They can tell you if your sample is too small or sufficient. They can tell you if you need to use one type of balance or a more precise type of balance. They can tell you if you need to use the small graduated cylinder or the large graduated cylinder. So how do I count significant figures? Well, before we start counting significant figures, we need to know how to read and write numbers in science. That seems pretty obvious, but it's a little bit different than math, so we need to know why. In math, you often deal with numbers like 12.00 or 12.000 or 12 or 12.0, and you might say these numbers all are the same. And in math, perhaps they are, but in science they're not. And they're not the same because numbers in science have a double meaning. They tell a scientist two things. They tell them how big or how small the number is, and in this case, its value is 12. But in science, we also care about the place of uncertainty. What kind of instrument was used to measure that number? So if you report a value as 12.00, you are telling the reader of your lab notebook that you used a balance that was good to the hundredths place. If you write just 12 grams, you are saying that the balance you used was only good to the ones place. Here, the balance is only good to the tenths place, and here the balance was good to the thousandths place. Now, in our lab, we often use a balance that is good to the hundredths place. So if you put a sample on the balance and it happened to read 12.00, and it was plus or minus 0.01 grams, you should not go to your lab notebook and write anything other than 12.00. If you do a shortcut and write 12 grams, that would be incorrect. And if for some reason you add an extra zero, that is also incorrect. The correct way to write it is just the way it appears on the balance, which would be 12.00 grams. This also tells you how many significant figures there are, and we count them very easily. That's 1, 2, 3, 4 significant figures. And 4 we'll learn later what the significance of that is. Let's say you go to a graduated cylinder now, and it's a little more difficult to read than a balance. And you have a graduated cylinder that's something like this, that has a 5 here and 6 here, and these little lines. These would be milliliters. Each of these little lines represent a tenth of a milliliter. You can estimate between these lines. So a tenth of a milliliter divided by 5 gives you a plus or minus range of 0.02 milliliters. And that is saying you think you can estimate between these lines that we would agree within a plus or minus 0.02 milliliter range. So if I read this, I should not write down 5 milliliters. Why? Because that implies the plus or minus is something in the ones place. But I just said it was something in the hundredths place. So our number must reflect this. So this would be wrong to write. This is also wrong to write. This implies I can read it to something plus or minus just in the tenths place, which is also wrong. What is proper is to write this as 5.00 milliliters, right? And it tells me two things. It has 5 milliliters, and I'm sure it's there plus or minus something in the hundredths place. In this case, somewhere plus or minus 0.02 milliliters of 5 milliliters. Right? So how many significant figures does this one have? 1, 2, 3. 3 significant figures this time. So I'm hoping you're starting to catch on. Let's try another one. Let's say you have another graduated cylinder, a much larger graduated cylinder this time. And it has markings that are 100 milliliters apart. And this is where the water is in the graduated cylinder, and we need to measure the bottom of the meniscus. And if there's a difference of 100 here, we can read this to 100 divided by 5, which is 20. So I should be able to read this to plus or minus 20. So what does that mean? We believe we can estimate that so that we agree within plus or minus 20 of each other and of 20 of the instrument. So it would be wrong if I looked at this graduated cylinder and just said, oh, it's closer to the 600 than it is to the 500, so I'm just going to say it's 600 milliliters. Well, we can do better than that. We can see that it's between the 500 and the 600, so that's wrong. It is also wrong to estimate more places than are possible. It would be wrong to read this as 565 milliliters. That means I could estimate this to something plus or minus the ones place. There's no way I can look at this and be certain that it is 565 if I don't think I could be good to plus or minus 20. This is too many digits. This is wrong. I'm not that good. I can't estimate that good. So what could I read this at? Well, I think it reads plus or minus about 560. Now you may have read it and said, I think that looks plus or minus I think that looks as good as 570. Well, that's okay because we are plus or minus 20 of each other. You might say that's 550 milliliters. That's good. We are still plus or minus 20 milliliters of each other and 20 milliliters of the instrument itself. So this is the proper way to do this. So let's count significant figures. 1, 2, 3, oops, that's not correct. Significant figures has the name because all the figures that you count have to be significant. I can only read this to something in the tens place, something in this place. That means this value is not significant. I cannot count that. So when I count the significant figures, I start reading from left to right, but I've got to stop at the place the plus or minus is. So if this is plus or minus something in the 20s place, I cannot count the 0 as significant. It is only 1, 2 significant figures. So if this is plus or minus in the 20s, which means it's in the tens place, these two numbers are significant, and I cannot estimate this last one. I don't know what this is. I don't know what the 0 is because I'm not sure it's really 6. So if I'm not sure it's really 6, there's no way I can guess what this one is. So 5 is significant, and this is in the plus or minus range, so it has significance also. This does not. So 1, 2 significant figures. So let's try some more. Maybe you're catching on here, and let's go back to an easy one. Let's say I take out one of our better balances that reads all the way to the 10th of a milligram, which is right here. So 10th of a milligram. So how many significant figures does that have? Well, where is the plus or minus? The plus or minus is right here. So I count from left to right. 1, 2, 3, 4, 5 significant figures. Wow, that's a lot of significant figures. And we'll talk about that too. Try another one. Say I go back to my other balance and I read this on the balance. 60.50 plus or minus 0.01 grams. So I read the significant figures from left to right, and I stop right here because this is the plus or minus range. So I count 1, 2, 3, 4 significant figures. What if I have another graduated cylinder that this time read plus or minus something 100? Okay, so I have 400 milliliters. Its plus or minus range 100 milliliters. So how many significant figures does this graduated cylinder have? Well, I start counting from left to right, and I count this one, but I have to stop because it's plus or minus something in the hundredths place. So I am uncertain about this number here. So if I'm uncertain about this number, it has some significance, but this 0 does not, this 0 does not. So this only has one significant figure, and that's the 4. If I'm not quite sure about the 4, there's no way this has any meaning or this has any meaning except to hold a place. So this has one significant figure. Let's say I have 400 milliliters, but I use a different graduated cylinder, and this graduated cylinder had different markings on it, and now the markings are in such a way that I can be certain up to plus or minus 20 milliliters. So I'm plus or minus something in the tens place. So how many significant figures does this have? I start counting from the left. I go 1, 2 significant figures. The last one, how about? I read it in a different graduated cylinder, which has a lot more markings. And this time, the graduated cylinder is good to plus or minus 2 milliliters. So now the uncertainty is in the ones place. So now, counting from left to right, I have 1, 2, 3 significant figures. So the significant figures depend where the plus or minus value is. Let's try one more thing that gives some people some difficulty, and that's with numbers that look like this. Let's say you go to our top loading balance, and this is what you measure. This is good to plus or minus something 0.01 grams. So you might count this, it's good to this place, so I might have 1, 2, 3, oh, that is not correct. I do not have 3 significant figures. Well, I started counting from left to right. I stopped at the place of uncertainty. So how many significant figures does it have? Well, you have to kind of remember what this value represents. Before you put anything on the balance, this is what it reads, nothing. You can zero it out. There's nothing on my balance, it reads 0. I can read it to the hundredths place, but there's nothing on my balance. There is none of these values are significant because they represent nothing. I just add a little speck of material and it gets to this. It now reads 0.01 grams. This value is the only one that had meaning, the 1 here. The rest was there because it used to have nothing on the balance. So this number here is the only significant figure that I have. So I have 1 significant figure. So let's talk about the rules of counting significant figures now that we have them. I'm going to start counting from left to right, but I have to start at the first non-zero number. So I go left to right, and I'm going to start counting at the first non-zero number. Where do I stop counting? I stop counting at the place the uncertainty goes to. This goes to the hundredths place, so I stop at the hundredths place. So I start at 1 and I stop at 1. I have 1 significant figure. Let's try another one on our fancy balance that reads to 1/10 of a milligram, and it reads this. And this is the plus or minus. It is somewhere here in the 10,000th place, or the 1/10 of a milligram. So let's count significant figures. I start counting from left to right, and I stop at the place of uncertainty, and I start at the first non-zero number. So going from left to right, that one doesn't count, that one doesn't count, that one doesn't count. I start here, 1, 2 significant figures. This has 2 significant figures. And I've got one last one. So here we have another one. It's a graduated cylinder again. And the graduated cylinder has a plus or minus value of 0.02 milliliters. So I start counting significant figures. I start at the first non-zero number, left to right. So this one counts. And this one counts because I can go to the hundredths place. So this has 2 significant figures. So there we have counting significant figures. What if, however, the person, you're reading their lab notebook and they don't give you the plus or minus values, so you don't have any of these values given. You don't know if it's plus or minus 0.01 gram or 0.02 milliliters or 100 milliliters or 0.00 grams. You don't know. All you know is the number that they write in their lab notebook. So all you know is a number that they've written down in their lab notebook. So how do I know how many significant figures there are in the numbers if I don't have the plus or minus with me? Well, first of all, we have to assume that they wrote them properly. So they wrote the numbers down so they didn't add extra zeros and they didn't write too few of zeros. They wrote them just the right way. So then we count to the place of uncertainty from left to right. So we have to guess, where is the uncertainty? Well, it's not really much of a guess for many samples. So let's say they wrote this down properly. So where is the plus or minus value? The plus or minus value should be right here. How do I know it's something in the hundredths place? Well, if they wrote it properly, this is where it is. If it really was the tenths place, they would have written the number like this, 12.0. If it was really something plus or minus in the ones place, they should have written it like this. If it was really something to the 10,000th place, they should have had more zeros. So the place of uncertainty is this 0. If they wrote this number right, the place of uncertainty is right here also, because otherwise, if it was in the hundredths place, they should have added an extra 0 like here, or if it was in the ones place, they shouldn't have written that one down. And so here's the place of uncertainty. If they wrote this right, the place of uncertainty is here, right at this 2. Right? If they meant the tenths place, they should have had 0.0. If they meant the tens place, they should have just read 10 grams and not 12 grams. So here is the place of uncertainty. And the place of uncertainty here is the hundredths place. Once again, if they meant the tenths place, they would have written it as 60.5. If they meant the ones place, they should have written this as 61 grams, not 60.50. So now we know the place of uncertainty. Let's count significant figures. Left to right, we have 1, 2, 3, 4 significant figures. Left to right, 1, 2, 3 significant figures. Left to right, 1, 2, 3, 4 significant figures. Left to right, 1, 2 significant figures. So those are all pretty obvious. But we had a problem when we were dealing with some of the numbers that were multiples of 10. What about this number? Where is the plus or minus value? Well, I can tell you where it's not. If it was something plus or minus to the 10th of a milliliter, they should have put 0.0. If it was something plus or minus to the hundredths place, they should have put it 0.00. They didn't do that. So where is the plus or minus here? Well, if it had been something like plus or minus 2 milliliters, the uncertainty would be here. But what if it was plus or minus something like 20 milliliters? They still would have written it like this, 400 plus or minus 20 milliliters. What if it was plus or minus something like 100 milliliters? They would have still written the number like this. So what if it was plus or minus 100 milliliters? They still would have written it like this. So I don't know. Is it plus or minus something in the ones place? Is it something plus or minus in the tens place? Or is it something plus or minus in the hundreds place? When it's a multiple of 10 like this, I don't know. So unless we get more information written down from your lab notebook or someone else's lab notebook, we have to take the worst case scenario. So it could be plus or minus something here, plus or minus something here, or plus or minus something here. I don't know. So we have to assume the worst case scenario, that it's plus or minus something in the hundreds place, not necessarily plus or minus something in the ones place. So how many significant figures? Only one. If I have more information, this would have 2 significant figures. If I had this information, this would be 3 significant figures. But if I get no more information, I have to assume the worst of those, 1 significant figure. So only when you get numbers like this do we have problems. When they're multiples of 10, you might have to guess plus or minus something here, here, or here. I don't know. When that's the case, you have to assume the worst case, that this only has 1 significant figure. So now that we know how to count significant figures, how does that tell us if we've taken a big enough sample? How does that tell us if we're going to have good results or not? Well, that all has to do with something called percent uncertainty. And we've talked about this in class already. So here are some values. Here are the plus or minus ranges. And here are their percent uncertainties. So how did we get the percent uncertainties? It's simple. The plus or minus range divided by the value times 100. So how is this related to significant figures and telling us if we have the proper equipment, the proper sample size, if we're going to get good results, if we're going to get bad results? Well, let's see how these 2 columns are related. So let's go back and count significant figures one more time. Good review. I'm going to start at the first non-zero number from left to right. So I start here, and where do I stop? I stop here also. So this has 1 significant figure. I'm going to give you a second, so pause the video and fill in the rest of this chart on some piece of paper. So yes, I really want you to do it. So pause the video and count the significant figures based on the plus or minus readings and tell me what you have. So I'm going to let you pause it and come back. All right, hopefully you actually paused it and now are back with me. And so let's go to counting the significant figures. So starting from left to right, this has 1, 2, 3 significant figures. This has left to right. Well, it gives me information here, plus or minus 100. So I go 1 and I have to stop here. So this only has 2 significant figures. This is what I'd have to assume also if they told me nothing. I'd have to assume 2 significant figures. The plus or minus range would have to be here. Unless they told me more information like plus or minus 1 or plus or minus 10. This number, 1, 2, 3 significant figures, easy to count. This number, I start at the first non-zero, 1, 2 significant figures. This, I first start at the first non-zero number, 1, 2, 3, 4, 5 significant figures. This one, once again, I wouldn't know unless they told me. They told me plus or minus 100, so this only has 1 significant figure. This has 1, 2, 3, 4 significant figures. And this, I start at the first non-zero, and I go 1, 2, 3, 4, because that's my place of uncertainty. I have 4 significant figures. So check your results. Did you get these same numbers? Same number of significant figures? Hopefully you did. And if not, go back and watch the beginning of the video. See if you can figure out what your mistakes were. So let's see if we can relate this uncertainty with Sig Figs. So what I've done is taken this chart and reordered it. So I put the ones together. So we have 2 values with 1 significant figure, a couple with 2, a couple with 3, a couple with 4. So let's see how they relate. So here's our chart reorganized. So look at how this column relates to this column. If you have 1 significant figure, the percent uncertainty is horrible, 20%, 50%. You can go up to 100%. If this was 100 grams, plus or minus 100 grams, you would have 100% uncertainty. That would give you terrible results. So anytime Anytime you get one significant figure in your data, you should go back and redo something. Take more sample, change your measurement tool. But you should not be happy with one significant figure because you are going to get very bad results. Maybe 100%. We do not want to be off by 20 or 50 or 100%. Look at what happens when you up the significant figures to 2. You are in a much better range. 6% error, 3% error. You can have 10% error. This is so-so data. Not too bad. We kind of like to be less than 5%, so maybe this is not too bad. So-so data. If you get 2 significant figures, I would still try to do something else if you could. Take more sample, change to a more instrument with more lines or a balance with more places, but change something. Look at what happens when we get 3 significant figures. The percent uncertainty is now under 1%. These are good values. You are going to get good results if you have 3 significant figures. 4 significant figures. The percent uncertainty is very small. This is great. Great. You're going to get really good results. Well, really great results if you have 4 significant figures. Okay? So you do not have to add more sample or take a bigger sample size. You are in a great range if you have 4 significant figures. And what about 5 significant figures? Oh my, look at that percent uncertainty, so small. This is what I call dancing in the streets. You're just so happy. You're so happy you have so many significant figures. So, there's a little lesson on significant figures. It's a quick way to count, to figure out how many significant figures you have, to give you an idea of your data. Am I going to be okay? Is this going to be bad? Is this going to be good? Am I going to be dancing in the streets because I have such great results? So there's our lesson. I hope you enjoyed it.